So this is lecture 8.5a, Division of Radicals, Elementary Algebra. So what we're going to do is basically follow the same procedure as far as simplifying radicals, but we're going to do some division. And one of the things to let you know, just like in the past where I would say the square root of 3 times the square root of 6 equals the square root of 18, which basically we got the square root of 18 by going square root of 3 times 6 equals the square root of 18. Division is very similar, whereas if we have the square root of 60 over the square root of 3, you could actually write that as the square root of 60 over 3. Now sometimes you'll get a problem that's written like this, and you're going to want to put them together into one big square root here. Okay? There are other times where you're given something like this, and you're going to want to break it into two square roots here. So how do you decide what you're going to do? Well, I know that I'm going to take the square root of 60 over the square root of 3 and break it into one, or make it into one big square root, because I know 60 over 3 is 20. Okay? And if I left it like that, I wouldn't necessarily know that. So that is pretty much the only time where you will switch from two radicals into one, is because then you can reduce this into a single number here. Okay? But usually what will be the case is you'll be given problems like this and you'll want to break it into two. Okay? But those are your two different options there when you're simplifying these division problems. So yeah, let's go to example 2. 6 square root of 20, and we're going to divide that by 2 square root of 5. All right, so when we have something that is written this way, we're going to look at the 6 over 2 and get 3. Then we're going to look at the square root of 20 over 5, and we're going to write it this way, and 20 over 5 is 4. Square root of 4 is what? 2. And we get 6 there. Okay? So, again, one of the things that's important is the numbers outside of the radical can be combined, and then the numbers inside of the radical you do some things with. So, we're going to continue on with this. And let's go to example 3. 5 times, cubed root, starting with these cubed roots already. Haven't even gotten used to the square roots yet. 4 cubed root of 2. All right, so again, we're going to look at it as 5 over 4. Okay, that can't be divided, so we're just going to write it as 5 over 4. And then we're going to look at this as the cubed root of 48 over 2, because I can look at this and say, oh, cubed root of 48 over 2 is going to be, put a times sign there, cubed root of 24. Okay? What is the cubed root of 24? There isn't one. There are not two numbers, or there is not a number multiplied by itself 3 times that gives us 24. So the next question is there a number multiplied by another number that I can take the cubed root of? So for instance, 6 times 4 equals 24. Well, can I take the cubed root of 4? No. Can I take the cubed root of 6? No. Is there another number I can multiply? There's 12 and 2. Can't take the cubed root of those. How about 8 times 3? Can I take the cubed root of 8? Yes, the cubed root of 8, which is what number times itself 3 times, equals 8, and it's 2. So the cubed root of 8 is 2. So I'm going to rewrite this as the cubed root of 8 times 3. And then I know the cubed root of 8, let's move some of this up. The cubed root of 8 is 2. So I'm going to pull the 2 out, and I can't do anything with the cubed root of 3. So see what happens here. Just as a reminder, we split our radical up into two numbers, and then we can take the cubed root of one of these numbers and pull it out, and the other number, which we cannot take the cubed root of, stays there. So now I can multiply that and get 5 times 2 is 10 over 4 cubed root of 3, and then I can reduce this to 5 over 2 cubed root of 3, like that. And one of the things that you can do, notice this isn't a fraction, but I can put it over that, and then I can multiply 5 cubed root of 3, just put those together, all over 2 times 1 is 2, and then I can write it as a fraction like that. That's what the book did there. All right. So what I want to do is go into the problem set and try a couple before we get into rationalizing the denominator. I don't want to just leave you with not much information here. So let's go ahead and look at some of the problems. So this is number 35. And before we get too carried away with this one, notice I have 4 over 2. We're kind of ignoring the radical sign for right now. We have 4 over 2. 4 over 2 is just 2 over 1, right? So I'm going to change that to 2 over 1. I'm just going to rewrite it here. 2x squared y squared. Okay, and I get that. So let's look at each part of these. Can I reduce this 2 at all? No, I can't. It's a prime number, so I can't do anything there. I don't know what the square root of 2 is, so the 2 will stay in there. Remember, I have an index of 2, so 2 goes into 2, x times, 2 goes into this 2 one time, so we bring the 1 out. And that's pretty much all there is to that. Okay, so we simplified our 4 over 2 before we really even got started with the problem, so that made things a lot easier for us. So let's look at 10. 8 square root of 35 over 16 square root of 7. So we're going to look at our 8 over 16, and we know that's 1/2. Square root of 35. What are our options there? 7 times 5 gives me 35, but can I take the square root of the 7 or the 5? No, I cannot. The square root of 7 here. Can I take the square root of that? No, I can't. Okay, so that means I'm going to go ahead and rewrite my square root of 35 over the square root of 7 to look like that, because I know 35 over 7 is 5. And we keep it under the radical sign there. So we take 1 times the square root of 5, and we get our 2 on the bottom, and we get an answer that looks like that, and we're happy with that. All right, so let's go back to the lecture and continue on learning this stuff. In this next section on page 565 is called rationalizing the denominator. Now what that means is whenever we write an answer that has a radical, we never are allowed to have the radical on the bottom. Okay, that is a no-no to have a radical in the denominator position. So we have to do what's called rationalizing the denominator, getting rid of the square root sign in the denominator. Now that's not the only reason we get rid of it, is just because we can't have it on the bottom, but we also do it because it helps us to solve the problem. So, for example, if we have the square root of 1/2, the square root of 1/2 can be written as the square root of 1 over the square root of 2. So notice this radical is on the bottom. So if you remember from previous lessons, remember when we had something like this, and if I squared it like that, it would cancel out with this 2 right here, this index 2, so these 2 would go away and the radical sign would leave, and we would have just the answer 3. So that's a pretty cool thing, that if this is squared, then all the other things go away except the radicand, the number underneath the radical sign. And that will come in handy as we are trying to solve and get rid of the radical in the bottom, like right here. So what we're trying to do is we're trying to change the square root of 2 to the square root of 2 squared, because then everything will go away and it becomes just a 2. Alright, so how do we just change that? Well, what we can do is if we multiply this entire problem, top and bottom, by the denominator that we're trying to get rid of, square root of 2 over the square root of 2. Because what did we just multiply this by? This over this, the square root of 2 over the square root of 2 is a number over itself, right? Any number over itself is equal to 1. So all I'm doing is really multiplying this equation by 1. And when you multiply an expression by 1, it does not change the value. So you can do that. So all we're going to do is rewrite this to look a different way. It's going to equal the same thing. It's just going to look different. So what is 1 times 2? 2. What is the square root of 2 times the square root of 2? And what do we know about the square root of a number squared? Everything goes away except the number under the radical sign. So this right here is actually this right there rationalized. The denominator is rationalized. Okay, so let's do that with the square root of 2/3. That equals the square root of 2. This is example 5. Almost wrote 5. Okay, and I've got a radical on the bottom. Don't want that. So what we're going to do is we're going to multiply top and bottom by this here. And it won't always be the case. It won't always be that you multiply this times itself. Sometimes, what we're trying to do is get it so that this number and my index here are the same. So whatever you have to multiply it by to get this number and the index the same is what you multiply top and bottom by. And I say that right now. We'll get into it later. Right now, you don't have to worry about it. But when we do, at least you'll be like, oh yeah, he did say we were going to do this. So 2 times 3, 3 times 3, equals square root of 6 over 3. Okay, you seeing how we're doing that? All right, let's go to example 6, and we'll start that on the next video.